Hello and welcome back to 90 Day Dental Day 44. So, I'm going to put you through a slightly different section today. We're starting off looking at soft tissue lasers, and we're going to start off by looking at the physics behind it before we move on to a bit more detail tomorrow. And sadly, you're going to have to put up with me for a bit longer today because this is one of my topics. I'll speak to you in a second. Right. So, welcome to an introduction to laser dentistry. My name's Ahmed. I've been your main host for 90 Day Dental for the past couple of weeks. And today we're getting into me wearing two hats. So I'm wearing my hat as one of the lecturers at BUILD, the British Institute of Laser Dentistry, as well, and being one of the lecturers from there. So we're going to start off by talking a bit about the actual physics of lasers first. So what lasers exist in dentistry? You've got two particular types. You've got soft tissue lasers and you've got hard tissue lasers. And today we're going to concentrate slightly on the physics behind it. And tomorrow we're going to touch into a bit more detail about what it can be used for. So the majority of us, being general dental practitioners, will only ever need to know how to use a soft tissue laser for our use in dentistry. Why would you use lasers in dentistry? So these are all the procedures that you could potentially ever need a laser for. And this is something that we'll be looking into a few times today and tomorrow, because it summarizes a lot of the important procedures. And it's everything from sort of coagulation, ablation or cutting, photobiomodulation, which is disinfection as well as decontamination, modified applications or miscellaneous applications. And so the types of lasers in dentistry are the sort of lasers that we've got here. We've got a combination of ones that utilize either carbon dioxide, argon lasers, we've got YAG lasers, ruby lasers, dye lasers, and they can be either soft tissue lasers or hard tissue lasers. Now, for our sakes, we're not going to concentrate on hard tissue lasers simply because 99% of us will never use a hard tissue laser. It will be a soft tissue laser that we'll ever need to use. And that's one of the main reasons that's what we're going to mainly concentrate on. So, if we remind ourselves of a summary of the electromagnetic spectrum, going back to our physics days, we're looking at the period or the area in the electromagnetic spectrum, which is in the infrared zone. So our composite curing light is in the visible light spectrum, whereas if we go into the infrared spectrum, that's where we are going to be talking about soft tissue lasers in dentistry, and especially diode lasers that we're concentrating on specifically. In this particular area, it's worth noting, if you think about it logically, that because it's not in the visible light spectrum, we actually can't see the actual laser beam because it's not in the visible spectrum. So it goes without saying that when you're using soft tissue lasers, we do need to consider eye protection, and we do need to consider trying to protect the eyes of everyone that's around us, simply because the laser could be working and could be on. We just can't see it because it's not actually in the visible spectrum. So that's something always worth mentioning. More specifically, the area that we're going to be looking into is the 810 to 980 nanometers region. So when a particular wavelength of laser hits a tissue surface, there are four things potentially that could happen. We can get full transmission through that particular surface. We can get full absorption through that particular surface. We can get full scattering, or we can get full reflection. And in reality, we get a combination of those four things. And what happens is determined by the density the power, the wavelength, the exposure time that the tissue is being exposed to, and also the type of tissue. And in our case, it's going to be the soft tissues that we're mainly going to be using. So diode lasers have been around in dentistry for well over 20 years now. It's a solid state semiconductor that works using a combination of gallium arsenide, aluminium, indium, all to turn electrical energy into light energy. And this is really one of the key points, because that allows that to be delivered through a fiber optic cable of a particular wavelength, which also allows this particular energy to be used against these the soft tissues in this particular case, to get all sorts of effects that we need, which is the hemostasis effects, the ablation or cutting effects, or the removal effects in contact mode. And in terms of the actual power, we're using powers anywhere from 1 watt all the way up to 10 watts in some cases. And we can change the pulsation on there, and we'll talk about that slightly later. That's a nice brief summary of that particular topic there. And we're going to look at a bit more detail of the procedures that we can use tomorrow. I hope that's been a useful introduction to some of the physics behind laser interactions. Tomorrow, we are going to delve a lot more detail into the actual process and the procedures that we can use it for and how it works. So join me back again then. See you then.